algebra folks. So in this video we're going to be talking about the first method of solving quadratic equations so that we can actually move on to more complicated methods in the future. But once we know how to solve this method, we're really going to get into the root of what it means in order to actually solve a quadratic equation. So you should be following along with your day 11 notes, and then afterwards you should be able to do day 11's assignment. So in our past lessons in trimester 2, we briefly talked about solving quadratic equations through factoring methods, and we only touched upon that very, very briefly. We're actually going to be going further in depth into that in our next lesson, but sometimes when we have quadratic equations, it's really not that deep. We can actually just do a little algebraic magic using our square root function on our calculator to do the work for us. So the reason why we would take the square root of a function is because if we think about what a quadratic function is, it's anything with, it's any expression or equation where the highest exponent is 2. So you could have like something like x squared plus 3x. And that would be a quadratic expression. And so the reason why we take the square root is because when our highest exponent is 2, sometimes we actually say that we're squaring something, right? And so naturally, the inverse operation in order to actually solve for x would just be doing square root, right? And so we would take the square root of this function in order to actually, or this expression in order to actually solve for x, right? And so when you take the square root of a number, you should actually end up with 2 answers for the most part. So let's say that we have a positive square root, right? We can assume that this is a positive square root because there's no plus or minus sign in front of it, so we can just assume that's a positive sign. So when we take the square root, the positive square root of 9, right, we would end up with 3. If we have a negative square root, right, we have a negative sign in front of it, so we know that whatever our square root value is, we're just going to put a negative sign in front of it. And then we can also have 2 values, right, and this is where that plus or minus comes in. So typically whenever you give the solution to a quadratic equation, you would say that this is plus or minus square root of 9 or plus or minus 3 to account for those 2 possible solutions, right? And so we read the symbol as plus or minus. So something that's important to note is that in Algebra 1, when you take the square root of a number, you should never be taking the square root of a negative number. And this changes in future math classes when you take maybe more complicated math classes where you can deal with complex numbers. But for the most part in Algebra 1, you don't deal with imaginary numbers, right? And when you take the square root of a negative number, you end up getting an imaginary solution. So in Algebra 1, we only deal with real solutions. And when I talk about real solutions, this means any number on a number line. So you can only take the square root of a number that you can find on the number line. So that means like something like square root of 3, totally okay. I can take square root of pi as well, right? That would also be okay, right? But at the end of the day, you should only end up with a real solution. If you were to take the square root of negative 3, right, your answer would not fall on the number line, right? Because you can't take the square root of negative 3 with just 2 real solutions. So just a note on your calculator, right? You should be working with your TI-84 Plus. If you don't have that and you're working from home, you can just use Desmos or Wabbit Emu. Emu is like a really good calculator emulator. But when you're taking the square root of any number, right, you want to press this blue button, and then this x squared button. Notice how above the x squared button, there's this tiny blue square root sign, right? We call this a radical. So because it's blue and it's tiny, that means that we have to press the blue button and that button in order to get the square root sign. So let's try our first example, right? So if we were to solve quadratic equations with square roots, let's say that we were given this equation, x squared equals 36. So what I would want to do is, because I see that my x is completely isolated, I just have to get rid of the square, right? So in order to get rid of the square, I use my inverse function, the square root, on both sides of my equation. And then, just to account for all possibilities, right, because this isn't given in any specific context, it's just like a math problem, right, I want to give the plus or minus version of my solution. So When I take the square root of x squared, I just end up with x, and then what's remaining is plus or minus square root of 36. And I know that I can actually calculate the square root of 36 in my calculator, right? Because 6 times 6 equals 36, right? And so my final answer should be x equals plus or minus 6. So why don't you try a problem on your own? So pause the video here to just try out this check for understanding where you're solving x squared equals 5 using your square root function. Once you've finished trying this on your own, you want to just press play so you can go over your answer. All right, you went over your answer? Let's try it together. So I have x squared equals 5. And I see that my x is completely isolated. I don't have any terms being added to it or multiplied to it. So I'm just going to go ahead and try to get rid of the squaring. And I get rid of the squaring by taking the square root on both sides. And so when I take the square root of x squared, I just end up with x. But to account for all my solution possibilities, I know that I have to take plus or minus the square root of 5. And now this already looks like one of my answer choices here. This looks like answer choice B. So I know that answer choice B is going to be my answer. However, if I actually wanted to estimate this, I would actually put square root of 5 in my calculator. And when I take the square root of 5, it should be around 2.23 plus or minus. Okay, so that's approximately my answer, and then my exact answer would be x equals plus or minus square root of 5. So let's take this a little bit further, right? So sometimes it's not going to be as simple as just taking the square root on both sides. Sometimes we actually have to do a little bit more algebraic work. So one thing that might be helpful is actually just treating this like a regular linear equation. Like you're just solving a regular linear equation. It's just at the last step, you just have to take the square root. So if we were given this equation, 2x squared plus 3 equals 131, my top priority is really just trying to get this x squared alone, right? So that I can do my square root at the end. So I'm just going to solve for this x squared first, right? So the first thing I'm going to do is just subtract 3 on both sides. So when I subtract 3 on both sides, I get 2x squared equals 128. And then I want to get rid of this 2 that's in front of my x squared. So in order to get rid of multiplying by 2, I'm going to divide by 2. And so I end up with x squared equals 64. So notice how I just used inverse operations the entire way until we got to x squared equals 64. Now, in order to solve for x, I'm still going to use that inverse operation idea, right? So I'm going to get rid of this squaring by taking the inverse operation of squaring, which is taking the square root. So I take the square root on both sides, and I get x equals plus or minus 8, because I know that the square root of 64 is, 8 times 8. And that gives me 64, right? So my solution is actually going to be x equals plus or minus 8. So take a minute and actually try this check for understanding yourself, where you're solving 3x squared minus 7 equals 5. Remember, just treat it like solving a regular linear equation, where you're just trying to get the x squared alone, and then the final step, just take the square root on both sides. When you're ready to check your answer, unpause the video. Ready to check your answer? Let's try it together. So I have 3x squared minus 7 equals 5. I'm going to try to get this x squared alone first. So the first thing I'm going to try to do is just get rid of this minus 7 by using the inverse operation. So the inverse operation of subtracting is adding. I'm going to add 7 on both sides. So I got 3x squared equals 12. And now I want to get rid of this multiplying by 3, this coefficient of 3. And I get rid of multiplying by 3 by dividing by 3. Once again, using my inverse operations. And I get x squared equals 4. And then finally, I want to get rid of this squaring. So I take the inverse operation of squaring, which is taking the square root. So I take the square root on both sides of my equation. And I just end up with x equals, and then remember, whenever I take the square root of a value, in order to account for all the possible answers, I want to take plus or minus the square root of 4, which I know is 2. So this should be my answer, and the answer choice that corresponds with that is D. So when you solve quadratics by taking the square root, you can have 3 different options for solutions, and this doesn't apply to just taking the square root, but these are just more clear-cut examples when we take the square root, right? So we're going to cover example 3a, where we have no solution, example 3b, where we have 1 solution, and example 3c, where we have 2 solutions. So in example 3a, we're given this equation x squared plus 1 equals 0. And if we were to actually try to solve for x, in this case using our square root function, right, we would first subtract 1 on both sides. So subtract 1 on both sides, and I get x squared equals negative 1. And then I want to get rid of the squaring, so I want to take the square root on both sides. So I do the square root of x squared and the square root of negative 1. Now, we talked about in our previous pages that in Algebra 1, we can't take the square root of a negative number. So we don't have any real solutions if we take the square root of a negative number. So in this case, in Algebra 1 at least, you would say that you have no solutions. It's not that solutions don't exist, but in Algebra 1, we have no real solutions, right? So if our equation requires us to take the square root of a negative number, the key point is that we have no real solutions. So let's try this out, right? When would our quadratic have no solutions? So we're given this quadratic equation, 3x squared plus 6 equals 0. We want to figure out what the solutions are, and we want to also explain how we know what the solutions are going to be. So take a minute to just pause the video here, solve this equation, and then write out what the solutions are and how you know. You have your problem? Ready to check your work? Let's try it together. So we have 3x squared plus 6 equals 0. So I'm first going to actually just, I'm just going to subtract 6 on both sides. And so when I subtract 6 on both sides, I get 3x squared equals negative 6. Now I'm going to try to get rid of this multiplying by 3 by dividing by 3. And I end up with x squared equals negative 2. Now, I have to take the square root on both sides to get rid of the squaring. So this would turn into x equals plus or minus square root of negative 2. Now I see that I'm taking the square root of a negative number, and so I would have no real solutions. And the reason why I know is because taking the square root of a negative number results in what we call imaginary solutions. So because you only end up with imaginary solutions, no solutions for your quadratic equation here, at least in Algebra 1. Let's look at example 3b, right? So this case, we're covering one, we would only have one solution. It's actually very special whenever we have this case, because let's say that we have something like x squared equals 0. So I don't have to actually solve for x in terms of getting rid of any extra terms, right? I just need to take the square root on both sides because my x squared is completely alone, so I just need to get rid of that squaring. So I'm just going to take the square root on both sides. And when I take the square root of 0, right, 0 is a non-positive, non-negative number. So 0 has no sign. No sign, okay? So because 0 doesn't have a sign, so it's not positive or negative, when you take the square root of 0, it's just 0, right? So there aren't going to be two different signed answers. So the key point of whenever your equation requires you to take the square root of 0, then you just have one solution, and your solution is just going to be 0, right? So if you write x equals plus or minus 0, that's implying that 0 has a sign, which it doesn't, so this would actually be labeled partially incorrect. So why don't you try out this check for understanding when your quadratic has only one solution, right? So what are the solutions for your equation? How do you know? And you're given the equation x squared minus 25 equals negative 25. So take a minute, pause the video here, try the problem out on your own, and then when you're ready to check it, press play. All right, you ready to check your work? Let's try it out together. So I have x squared minus 25 equals negative 25, and what I want to do is actually just solve for x, right? So I'm going to add 25 on both sides to try to get my x squared alone. And so when I do that, I get x squared equals negative 25 plus 25 gives me 0. I need to take the square root on both sides to get rid of that squaring, so I get x equals 0, right? And I wouldn't write that plus or minus sign in front of the 0 because 0 has no sign, right? And so my solution is just x equals 0. That's it. And the reason why I know is because taking the square root of 0 results in only one solution because 0 does not have a sign. It's not positive, it's not negative. Right? So your solution just should be x equals 0. In example 3c, in this case, your quadratic would actually have two solutions. So let's look at this, right? We're given the equation x squared minus 1 equals 0. And so once again, the first thing that we want to do is actually just solve for your x squared, try to get it alone. And so what you're going to do is just add 1 on both sides. All right, so if you add 1 on both sides, then you end up with x squared equals 1. And then what you want to do is actually just take the square root on both sides to get rid of that squaring. And then you end up with x equals plus or minus 1. Right, so because the number we're taking the square root of is not 0 or a negative number, it's safe to assume we have both a negative and a positive number. So if your equation requires you to take the square root of a positive non-negative number, then we have two solutions, right? So as long as your number is positive, it's not 0, right, you're good to go. Now, whenever you expand this out into real-world settings, you're going to have to change how you think about how many solutions your quadratic has. And this is mainly just because, let's say that you're solving for the maximum area or the maximum width of like a rectangle, right? And so in that case, you could end up with two solutions, right? But then only one of those solutions would matter because you can't have like a negative width, right? So it all just matters about context. So if your context says that you can't have a negative solution or you can't have a positive solution, then you just have to strike one of those solutions, just given your real world scenario. Right, so let's try out this check for understanding when your quadratic has two solutions. So if you were just given a pure equation, x squared minus 16 equals 0, what are the solutions for the equation and how do you know? So press pause here, try this out on your own, and when you're ready to go over the answer, press play. Ready to check your answer? Let's try it together. So I'm given x squared minus 16 equals 0. I want to get this x squared alone, so I'm going to add 16 on both sides. And when I add 16 on both sides, I get x squared equals 16. I'm going to take the square root on both sides, get rid of my squaring, so I get x equals plus or minus 4, as 4 is the square root of 16, right? And so my solutions are going to be x equals plus or minus 4. And remember that this plus or minus tells me that I have two solutions, right? So this is my first solution, x equals positive 4, and my second solution would be x equals negative 4. But instead of writing all that out, I can just use this handy symbol, plus or minus. And the reason why I know is because taking the square root of a positive non-zero or non-negative number results in two real solutions unless otherwise noted, right? And when I say unless otherwise noted, that means if you're given the context that like you're just trying to find time or something, you can't have negative time, right? Or you're trying to find distance, like you can't have negative distance, right? So at the end of this, right, this is our last check for understanding. You should be able to work through assignment number 11. If you're still having problems with this, feel free to email me. If you're having trouble with one of the particular examples, I really encourage you to just go back and look through it again, try to work through it yourself. All right, good luck.